Imagine the silence of space. No air, no sound, only endless blackness stretching in every direction. For most of human history, we believed that silence was permanent, unchanging, that the heavens above us were fixed, eternal. But the truth has always been more complex. The universe is alive, dynamic, and restless. And every so often, it throws us a surprise that reminds us just how little we really know. In August of 2025, astronomers working with the James Webb Space Telescope announced something extraordinary: the discovery of a brand new moon orbiting Uranus. At first glance, it might not seem earth-shattering. After all, Uranus already had 27 known moons. What difference does one more make? But the truth is that this discovery matters, and it matters deeply. Because in science, sometimes, the smallest details unlock the biggest mysteries. The new moon, provisionally named S2025-U1, is no more than 10 kilometers across. It is, in cosmic terms, minuscule, smaller than many cities here on Earth. Yet hidden within that tiny sphere is a story billions of years old, a story of chaos, collisions, and cosmic survival. Think about it. Uranus has been observed for centuries. Discovered in 1781 by William Herschel, it was the first planet to be found with a telescope. Voyager 2 passed it in 1986, sending back breathtaking images of its pale blue atmosphere, its rings, and its moons. Countless astronomers since then have turned their instruments toward Uranus, studying its strange tilt, its icy composition, and its faint rings. And yet, here in 2025, a brand new satellite was still waiting to be revealed. That fact alone should make us pause. If something as large as a moon, even a small one, could remain hidden until now, what else in our solar system have we yet to find? How many other worlds are circling quietly in the dark, waiting for our technology to become advanced enough to notice them? The James Webb Space Telescope, launched in 2021, was designed to peer deeper into space than ever before. It can capture the faint light of galaxies formed billions of years ago. But here it was, being used to look much closer to home. While studying Uranus's faint rings, astronomers noticed a subtle point of light. At first, it could have been dismissed as noise or mistaken for a distant star. But when they compared exposures taken over several nights, they realized the light was moving. Not randomly, not drifting, but in a steady path that matched Uranus's orbit. This was no star. This was no illusion. This was a moon. The discovery reminds us of an uncomfortable truth. Our solar system is still full of secrets. We live in an age where satellites map every inch of Earth's surface, where probes have flown past Pluto, and where rovers crawl across the surface of Mars. And yet, we are still finding new neighbors orbiting the planets closest to us. But why does this matter? Why should you care about a tiny rock circling Uranus, almost 3 billion kilometers away? The answer lies in what that rock represents. It represents a missing piece of Uranus's history. It represents a chance to test theories about how planets form, how moons are born, and how chaotic events shape entire worlds. And most importantly, it reminds us that discovery is never finished. Over the course of this documentary, we will explore this discovery in detail. We will examine how S2025-U1 was found, what makes it different from other moons, and why its existence forces scientists to rethink parts of Uranus's story. We will travel back to the violent early days of the solar system, when impacts and collisions scattered debris everywhere. We will look forward to the future, to the telescopes and missions that may reveal dozens more moons hiding in plain sight. And by the end, you will see that this is not just the story of a small rock around a distant planet. This is a story about us, about our curiosity, our persistence, and our place in the universe. So settle in. What you are about to hear is more than astronomy. It is a reminder that the cosmos is alive with secrets, and that every time we think we've reached the edge of knowledge, the universe whispers, "Not yet." The discovery of Uranus's new moon, S 2025 U1, did not happen overnight. It was not a single eureka moment, but rather the result of patience, precision, and a telescope powerful enough to see what had been invisible for centuries. For much of history, Uranus was one of the least understood planets in our solar system. Even today, many textbooks devote only a few pages to it. Unlike Saturn, whose rings dazzle the eye, or Jupiter with its massive storms, Uranus often sat in the shadows of public fascination. Yet its quiet nature masked deep mysteries, and this discovery is proof that even the overlooked worlds have stories to tell. The story begins with the James Webb Space Telescope. Launched in December 2021, Webb was primarily built to study the earliest galaxies, stars, and the formation of planetary systems far beyond our own. But astronomers have also turned Webb toward objects within our solar system, using its extraordinary sensitivity to uncover details that older telescopes missed. Uranus, with its faint rings and unusual tilt, was a perfect candidate. In mid-2025, astronomers aimed Webb's near-infrared camera, NIRCam, at Uranus to capture its rings. Unlike Saturn's bright and reflective ice rings, Uranus's rings are dark, thin, and difficult to see. Webb's infrared vision allowed researchers to peer into these faint structures with unparalleled clarity. But in those images, among the faint arcs of dust and ice, a tiny dot appeared, a point of light that did not belong. At first, astronomers suspected it might be a background star. After all, the sky is filled with countless stars, and Uranus moves across them as it orbits the Sun. But something was strange. When images taken over multiple nights were compared, this faint dot was not fixed like a star. It moved. Slowly, but consistently, it tracked alongside Uranus. To confirm their suspicion, astronomers conducted weeks of observations. They measured the dot's brightness, its path, and its speed. Computer models simulated possible orbits. The conclusion became undeniable. This was not a star, not a background galaxy, and not an imaging artifact. This was a moon. The official designation came next, S 2025 U1. S stands for satellite. 2025 is the year of discovery. U for Uranus, and 1 means it is the first Uranian moon found in that year. It may not have the poetic Ring of Titania or Miranda, but this alphanumeric name is only temporary. Eventually, like all Uranian moons, it will be given a name inspired by Shakespeare or Alexander Pope. Perhaps it will be christened with a name from A Midsummer Night's Dream, joining Oberon, Titania, and Puck. Its size is modest, around 10 kilometers across, perhaps smaller. That makes it more like an asteroid than a traditional moon. But even small satellites can have outsized importance. The discovery of Amalthea, around Jupiter, or Pan and Daphnis within Saturn's rings, proved that tiny moons can shape entire planetary systems, stirring dust, carving gaps, and influencing rings with their gravity. S 2025 U1 may be playing a similar role around Uranus. This is not the first time Uranus has surprised astronomers. In 1977, while scientists were observing a distant star passing behind Uranus, they noticed the star's light dimming repeatedly, the first evidence of Uranus's ring system. Nearly a decade later, Voyager 2 revealed the planet in detail, capturing images of its tilted axis, faint rings, and moons. Those discoveries painted Uranus as a far stranger and more dynamic world than previously thought. Now, decades later, Webb has added a new chapter to the story. The broader significance is this. Even in the year 2025, with advanced telescopes and decades of exploration, Our solar system is not fully mapped. New worlds can still be hiding in plain sight, waiting for the right technology and the right eyes to find them. The new moon, S2025U1, may be small, but its features are fascinating, and they tell us more than just numbers on a chart. It is roughly 10 kilometers across, tiny compared to most moons, yet still large enough to be gravitationally bound into a sphere-like shape. At this size, it may not be perfectly round like our moon or Titania, but rather irregular, perhaps potato-shaped, scarred with craters and fractures from billions of years of cosmic collisions. To understand what makes S2025U1 important, we need to place it in context. Uranus has 27 known moons before this discovery. These moons fall into three main groups: the large classical moons like Titania, Oberon, and Ariel, the smaller inner moons that orbit close to the planet and interact with its rings, and the outer, irregular moons, which likely were captured asteroids. Each of these moons tells a different part of Uranus's story. Where does S2025U1 fit? Based on its orbit, it appears to belong to the inner group. This means it might play a role in shaping Uranus's faint rings. Small moons can act as shepherds, keeping ring particles in place, sculpting their edges, or generating faint arcs of dust. If this is true, S2025U1 could be one of the reasons Uranus's rings look the way they do today. Its size also suggests it could be a fragment, a leftover piece from an ancient collision. In the early solar system, impacts were constant. It is possible that a larger moon once orbited Uranus, only to be shattered in a violent event. S2025U1 could be one of the surviving pieces, still circling billions of years later. If this is true, studying it may give us a glimpse into Uranus's violent past. The surface of such a tiny moon would likely be heavily cratered. With little or no atmosphere, it cannot protect itself from impacts. Every small rock that has struck it over the last 4 billion years is still recorded in its surface scars. Unlike larger moons, which may have geological activity to resurface and erase old craters, S2025U1 is frozen in time, a fossil in orbit. Comparisons help us see why it matters. Earth's moon is 3,474 kilometers wide. Titania is 1,578 kilometers. Oberon, 1,523 kilometers. By contrast, S2025U1 at Warchitzer 10 kilometers is a grain of sand next to boulders. Yet history has shown that even small moons can have powerful effects. Pan and Daphnis, two moons of Saturn only a few kilometers across, carve distinct gaps in Saturn's rings. Amalthea, a small moon of Jupiter, influences Jupiter's ring system. These examples prove that size does not determine importance. Another question astronomers are asking: what is it made of? At that distance from the Sun, Uranus's moons are generally composed of a mixture of ice and rock. S2025U1 is probably no exception. If it is primarily ice, it might reflect more sunlight than expected, making it slightly brighter. If it is rockier, it could be darker and harder to see. Determining its composition will take time, but the clues are already there in its brightness and reflectivity measured by Webb. Its orbit also provides hints. Early calculations suggest S2025U1 circles Uranus at a distance of tens of thousands of kilometers. Its orbital path could place it between the planet's faint inner moons and its ring system. If true, then it may be part of the delicate balance that keeps Uranus's rings stable. Without shepherd moons, rings can spread and dissipate over time. With them, rings can survive for billions of years. Finally, there is the question of stability. Will this moon survive forever? Astronomers note that small moons close to giant planets can be unstable. Over millions of years, tidal forces can pull them inward, eventually causing them to break apart or crash into the planet. If S2025 U1 is on such a path, it may one day contribute its material to Uranus's rings. In this sense, it could be both a moon and a future ringmaker. In short, the features of S2025 U1 tell us it is not just a random rock. It is a small but significant part of Uranus's system, a player in the dynamics of rings, a witness to ancient collisions, and a reminder that even the tiniest objects can hold cosmic importance. Why should we care about a tiny moon orbiting Uranus? To the casual observer, it may sound trivial. Another rock circling a distant planet far from Earth with no effect on our daily lives. But the reality is that S2025 U1 is more than just a rock. Its discovery reshapes how we think about Uranus, about the solar system, and even about the fragile, chaotic process of planetary formation itself. First, every new moon gives us a new data point. Scientists don't just catalog these objects for fun. Each one is a piece of the puzzle. When we add S2025 U1 to the system of Uranus, we gain a new clue about how that system formed, how it has evolved, and what it might look like in the future. Moons are not passive passengers. They are active players in shaping the history of their planets. Uranus itself is a mystery. Unlike the other giant planets, it is tilted almost completely on its side. Its axis of rotation is tipped by about 98 degrees. Imagine a spinning top lying nearly flat as it turns. No other planet in the solar system is like this. The leading theory is that Uranus suffered a catastrophic collision billions of years ago, perhaps with a protoplanet the size of Earth. That impact may have knocked the planet over, altering its axis forever. If S2025 U1 is a fragment from such a collision, then it is a fossil, a preserved shard of Uranus's violent history. Small moons also interact with rings in ways we are only beginning to understand. At Saturn, tiny moons shepherd rings, carving out gaps and maintaining sharp edges. Without them, rings would diffuse and vanish over time. If S2025 U1 plays this role at Uranus, then its existence may explain why Uranus's faint rings still exist at all. The rings themselves were only discovered in 1977, a reminder that even in the modern era, our closest cosmic neighbors can surprise us. The discovery also reminds us of humility. Think about this. It is the year 2025. Humanity has walked on the moon, sent rovers to Mars, landed probes on asteroids and comets, and even flown spacecraft past Pluto. We have telescopes that can peer back to the dawn of the universe. And yet, we are still uncovering moons around the planets next door. The solar system, which we often assume to be fully charted, is not finished revealing its secrets. There are practical reasons, too. Understanding moons helps us plan future missions. If NASA or another agency sends a spacecraft to Uranus in the 2030s, a mission already under discussion, then knowing the exact number and location of its moons will be crucial. A small, previously unknown moon could pose hazards to spacecraft or, conversely, offer new opportunities for science. Every detail matters when you are navigating a billion-dollar mission billions of kilometers from home. On a deeper level, S2025 U1 symbolizes the beauty of incremental discovery. Science is not always about giant leaps, about finding Earth-like, exoplanets, or imaging black holes. Sometimes it is about the small, quiet revelations that remind us the cosmos is always more complex than we imagined. This moon is a reminder that the frontier of knowledge is not far away in another galaxy. It is right here, in our solar system, in places we thought we already understood. And finally, there is the human element. We are explorers by nature. Our ancestors looked up at the sky and mapped the stars with nothing but their eyes. Galileo turned a crude telescope to Jupiter and saw moons circling another world. Proof that Earth was not the center of everything. Centuries later, astronomers using the James Webb Telescope have extended that tradition, showing that discovery never ends. Each new moon, no matter how small, is part of that unbroken chain of a curiosity. S enter 2025. U1 may never host life, may never be colonized, may never even be visited by a spacecraft. But its existence changes us. It adds one more thread to the tapestry of the universe. It tells us that there are still surprises waiting, even in familiar places. And perhaps most importantly, it reminds us that our quest to understand the cosmos is not about utility alone. It is about wonder. The discovery of S2025U1 does not just tell us something about Uranus. It points us toward the future, to what lies ahead in humanity's exploration of the outer solar system. For decades, Uranus has been the forgotten giant. Jupiter and Saturn received flagship missions, with spacecraft orbiting them for years. Neptune and Pluto, though visited only briefly, have fascinated the public with their striking images. But Uranus has had only one close visitor. Voyager 2 in 1986, nearly 40 years ago. Since then, we have relied solely on Earth-based telescopes, Hubble, and now James Webb. That is about to change. NASA and other space agencies are seriously considering a Uranus orbiter mission in the 2030s or early 2040s. If approved, this would be the most ambitious journey into the outer solar system since Cassini at Saturn. A spacecraft circling Uranus could spend years studying its atmosphere, rings, magnetic field, and moons, including S2025U1. Imagine the first close-up photographs of this new little world, transforming it from a faint dot into a landscape with craters, ridges, or icy plains. The scientific rewards would be immense. Studying Uranus and its moons could reveal how ice giants form, how magnetic fields work in extreme conditions, and how moons interact with rings. These lessons are not just academic. They could help us understand exoplanets orbiting distant stars. Many of the worlds discovered by telescopes like Kepler and TESS are Uranus-like, ice giants, tilted and stormy. By studying Uranus here, we learn about planets across the galaxy, and it is not just about science. Missions like these capture the imagination of the public. Just as Cassini's photographs of Saturn's rings or Hubble's deep field images inspired a generation, a Uranus orbiter could remind humanity that exploration is a shared adventure. It could make children look up at the night sky and dream, just as Voyager once did. But until that mission becomes reality, discoveries like S2025U1 keep the story alive. Each small moon, each faint ring, each subtle atmospheric detail keeps Uranus in the spotlight and gives scientists fresh reasons to push for exploration. In that sense, this tiny moon is a political ally, helping to secure the arguments for funding the next great voyage. There are also deeper philosophical implications. Every time we find something new, no matter how small, we are reminded that the solar system is not finished. It is dynamic, evolving, and full of mysteries yet unsolved. If Uranus, a planet we thought we understood, can still reveal surprises, what else might we be missing? Are there more moons hiding in the glare of the planet? More faint rings waiting to be discovered? Entire processes we have not yet imagined. Discovery, after all, is endless. A century ago, we did not know about Pluto. 50 years ago, we had never seen the outer planets up close. 30 years ago, exoplanets were still hypothetical. Today, we are mapping them by the thousands. And tomorrow, perhaps we will find life in the clouds of Venus, oceans beneath Europa, or civilizations orbiting other stars. Each step builds on the last. S2025U1 is one of those steps. So, what should we take away from all this? That wonder is alive. That curiosity is not optional. It is part of what makes us human. This moon may never be famous. it may never appear in school textbooks, but it adds to the collective story of who we are. Explorers on a tiny world, looking outward, searching for meaning among the stars. As we close this journey, imagine looking at Uranus through a telescope. Picture the pale blue disk, faint rings encircling it, and now, in your mind's eye, add one more companion. S2025, U1, a silent traveler in the dark, invisible to the naked eye, but real, undeniable, and waiting. Perhaps, one day, a spacecraft will fly past and capture its frozen surface in stunning detail. Perhaps future generations will walk under alien skies and remember that it all began with faint dots of light, tracked patiently by astronomers on Earth. Until then, the moon is ours to imagine. And in that imagination, in that shared sense of wonder, lies the true meaning of discovery.